In search of gold, we lost diamond. So many of you might probably know about this expression, right? This is just the Leibniz formula, which generalizes the nth derivative of a product. And this over here is the formula for nth derivative of quotient, right? Many of you might already know about this formula or also know the proof of this formula. If no, I will just link the proof of this formula in the comment section or description, or yeah. But yeah, in this video we will basically prove this formula for nth derivative. Yeah, but before we go to that, let's see. Let's see what our conditions are over here. U and B are just basically a function of x, right? And this u prime basically denotes the first derivative, second derivative, third derivative, right? So the number of like dash represents the nth derivative. For this video, we will basically denote, let's say, the nth derivative of u with respect to x, right, as capital Dn of u, and nth derivative of b as dn of v. And this will make our life easier. Now, yeah, I guess you guys know this formula, and this can also be written as in this way. Let's say if I want the nth derivative of this product of u function and b function, which are both function of x, right? In that case, this will just be equals to the sum from r equals to 0 to n of ncr rth derivative of u and n minus rth derivative of b. So yeah, this is the formula. Or you can also write it as either way, it doesn't matter. You can also write it as n minus rth derivative of u and rth derivative of p. Okay. Now, yeah, just you can maybe use this formula to, let's say, find the nth derivative of e to the power x sin x, right? Maybe it's triple derivative. You can use this formula. Even for fourth derivative, you can use this formula. So this formula is helpful, but yeah, that's not the goal of this video. The goal of this video is basically to prove this formula. Now, the reason we need this formula is even though we can express this formula from over here itself by writing it as u b inverse uh, to the power like nth derivative, like finding the nth derivative of inverse becomes really complicated. So this formula basically if, just uses the derivative of b's only to get the derivative for inverse, and we don't need the b inverse to use this formula, right? So that's why this is helpful. Now let's try to prove this formula. And to prove this, we'll basically first of all go from let's say their second derivatives and first derivatives as well, and then we'll slowly come to third derivative, and then we'll also go to fourth derivative. But on the way, we will definitely prove this formula over here. And yeah, I believe this will be helpful for a lot of you. Okay. So okay. So now how do we come up with this one? So we don't really have any other things except this tool, right? So we will definitely make use of that. So first of all, let's say this u by b is a function of x, right? And our goal is just to find the first derivative of x, second derivative of x, third derivative of f of x, and let's say nth derivative of f of x, right? Our goal is just to find the nth derivative of this function u by b, right? So what I will now do is I will write, and yeah, like linear algebra will become really handy in this video, in this proof. B times f of x. Also know that both of these b and u's are also function of x. Okay. Now what I'm gonna do is, let's say if I differentiate both sides with respect to x, if I differentiate both sides with respect to x, this will become basically the derivative of u will basically become derivative of b f of x plus b times derivative of f of x, right? Okay, now using this, how can I find the derivative of f of x? Over here it's easy, you can actually find f of x is just u by b. You can substitute over here and then get the df of x, right, in terms of u and bu only. But uh, like we will try to do it a bit differently so that it will be helpful later on. Over here we know that we can I can write it write 0 times df of x, right. The reason I'm doing this is so that this will be kind of linear equation with f of x and d of x being our variables, and these things are just acting like our constant, these numbers. We can solve this equation we can solve for f of x and d of f of x using like Cramer's rule or any other ideas to solve the equations, right. Now if I use Cramer's rule, I guess you guys know that if I want to solve, let's say ax plus by is equals to c, and cx plus dy is equals to e. Sorry, let's say this is f. The solution for x will basically just be the determinant, where first of all in this our denominator will just be determinant of this thing. I mean the coefficients in there, and this is a c b d, and in numerator we will just have this column where there is x, that column being replaced by fe. So this is just fe b d, right. Again, as for y also that's same. Denominator will just have the same determinant, and in numerator the column where there is y, this bd, will be replaced by fe. And that's same for any number of dimensions, not just for 2. This is 2-dimensional. For any dimension that's true. Okay, so over here if I want to find d of f of x, if I just use the Cramer's rule, what I will get is this will just be in denominator, that will be determinant of b d of v 0 b, right. In numerator that will just be okay, in numerator what will happen is basically the we are trying to find d of f of x, right. So this column where this column over here, the coefficients of d of x will be replaced by these things from the according to Cramer's rule, right. So this will just be b d of v times u d of u. So yeah, this is the formula, and this is the formula just involving u and v to find the first. Now we know that f of x is just u by v, so the derivative of u by b will be this thing. And now notice that you typically want to write u in front of b and b at the back side, right. So if we change that order, there will be minus sign, -1, and the denominator is just b square because there's 0 in this side, so b square minus 0 times db will just be 0. Sorry, so it will just be b square minus 0, so that's b square. And determinant of now this negative sign is because we changed the order of the column, right. If we just swap with the columns, there will be negative sign in front, so b dv. So yeah, this is the expression for just the first derivative u by b, right. And now we will go on progressing and reach this eventually. Okay, so now I guess you get the feel of how we are doing it, right. And if you get the feel, you can just go on trying on your own actually. Yeah. Okay, so now again let us say that u by b is f of x, so that u is equals to b f of x, right. Now let's take the first derivative. So this will be d of u will be now if I use product rule, this will just be b, okay, derivative of b f of x plus b times derivative f of x, right. Now again, if I want to find second derivative of this expression, right, over here this will be easy, right. Over here it will just be second derivative of u, right. But over here for this product b f of x, if I want to find the second derivative for this product, right, again I need to use the same Leibniz rule. And how will you do this? This will just be first of all 2c0, and okay, the second derivative of b, no derivative of f of x, plus f of x, 2c1 first derivative of b, first derivative of f of x, right. Again 2c2 no derivative of b, and then second derivative of f of x. So the thing is, this is just like power. This derivative is just like power, like how you used to do the binomial formula, right? It's the same like concept. Like first of all, there are two c's, there are two c1, two c2, right? And then over here, just like the binomial, the power, the derivative for the b is decreasing, right? And the derivative for the f is increasing, right? It was first of all no derivative, first derivative, second derivative. I guess you get the idea, right? So yeah, now if we use that over here, this will just be d square of b times f of x plus, now 2c0 is 1, 2c1 is 2, this is 2 times d of b d of f of x plus, now again 2c2 is just 1, right? So 1 times b times d square of f of x. Okay, now again we want to solve this equation, right? And now like we will consider this as the equation of three variables, f of x, d of f of x, d square f of x, right? And again, to make this like a similar equation, I can write this as 0 times d square f of x, right? And then again I can write it over here as 0 times d of f of x plus 0 times d square f of x. This makes it seem like three equation of three variables, right? Okay, now we want to solve for just d square f of x. And again, if you use Cramer's rule, I guess you have the idea, right? How to use Cramer's rule. Let's say I have a1 plus a2 plus a3, a1x plus a2y plus a3z is equals to a4, b1x plus, oh wait, how did I have yeah, three equation three variable, good. Now b1x plus b2y plus b3z is equals to b4, c1x plus c2y plus c3z is equals to c4. Now if I want to solve for, let's say, z, what I will do is, in denominator I will just have determinant of all these coefficients, a1, a2, a3, b1, b2, b3, c1, c2, c3, right? In numerator we will just replace this coefficients of z, that's what we are finding, right? The variable which we are finding, we need to see its coefficient and then replace that by this coefficients at the other side. a1, b1, c1, a2, b2, c2, and this is a4, b4, c4, right? So this is our g. That's our g, guys. I guess you get the idea, right? Guess you get the idea. This is our g. Okay. So now, okay, using that, I can find d square f of x as in denominator. Okay, wait, this will not be enough. This space is not enough, I guess. So yeah, d square f of x. In the denominator, it will just be determinant of all the coefficients, right? B, D of V, and this is easy to predict. For the first one, this is just like B and then 0, 0. Now first derivative of B and then just B only, 0. Now here's like second derivative of B, and along with the binomial coefficient, the first derivative of B, right? And then there's just B. So yeah, it's easy to write. And for the upper one, okay, since we want to find the last column, right? This d square f of x. Just these have to be replaced by u, d square u, this column, or everything else will be same. So b, db, d square b, right? 0, b, 2 db. Now this has to be replaced because this is the thing that I want to find. Replaced by this thing over here, u, du, d square u. And you might already notice that there's a pattern. But for this one, it's just the same expansion without the f of x, right? The f of x, d f of x, d square f of x, same expansion over here for this one. And for this one, like same determinant in denominator, but the last column being replaced by u, d square u, d cube u, and such things. So yeah, this pattern is pretty obvious right now. And yeah, now like if you wanna bring this u in front, Again, also notice that like this denominator in the this determinant in denominator will just express to b cube, and like this is always like in the form of bit, like in the next derivative, this will just be to the power 4, then b to the power 5, b to the power 6. It will just be the power of b, and that's a really good observation and result. So over here, if we try to evaluate, this is just b cube, right? So I can write this as, I can write d square f of x as 1 by b cube derivative of b d square b 0 b 2 dv u du d square u, right? Okay, that's good. Now like most of the time, if we just try to write u in front, if we do that, okay, first of all, to take the u in front, first of all we need to swap these two, right? So that u will be in second and 0 in third. That will introduce a negative sign determinant. Again, now u is here, b is here, right? Again we need to swap these two, right? So that now u is here, b is here, 0 is here. So yeah, since there are two swipes, we will have two negative signs being multiplied, which makes it eventually plus. So yeah, the moral of the story is, if you wanna take this u to the first thing, b to the second, u to the o to the third. Now for this case, since they are odd numbers, there will just be even number of swaps for u, and then so yeah, the negative sign cancels out. I guess you get the idea what I'm saying. So yeah, if even for this case, even if you swap this u at the to the front and then move all of them, just like a cyclic permutation, sign won't change. But that's not always the case. It's only the case for this one. The cyclic permutation isn't changing the sign, right? Yeah. Okay, so I just told you what I can do, and sign won't change, right? Okay, so this is 1 by b cube u du d square u b dv d square b 0 b 2 dv. Okay, now let's get to the one that we were intending to find in this video, right? Okay, now, and we'll also guess the expression for the fourth one. Now u is again u by b is f of x, right? So okay, so we know that u is just b f of x, where u and b both are function of x, right? And then now again, if I just take the first derivative, this will just be derivative of u is equals to derivative of b f of x. Let me write it in a proper manner. Let me not just write it in the first way. Okay, derivative of u is equals to derivative of b f of x plus b derivative of f of x, right? Now if I take second derivative, I'm sorry. If I take second derivative, this will just be second derivative of u is equals to over here. So basically now 2c is 0. It's just 1, and then derivative of b, the second derivative of b. Let me write the numbers as well. So 2c is 0, second derivative of b, nothing of f, and then 2c1, first derivative of b, first derivative of f of x, plus 2c2, nothing of b, second derivative of f of x, right? Okay, now if I want to find third derivative, there'll just be dq of u. And in this side, if I find third derivative, again using the same Leibniz formula, this will just be 3c0, third derivative of b, nothing of f, and then 3c1, this will just be second derivative of b, first derivative of f of x, right? And then 3c2, nothing of b, second derivative of f of x, and then 3c3, just b, and then just b, and then third derivative of f of x, right? And as usual, I can make this 0 times third derivative of f of x, right? I can also make this as 0 times second derivative of f of x plus 0 times third derivative of f of x plus 0 times f first derivative of f of x plus 0 times second derivative of f of x plus 0 times third derivative of f of x. Okay, so now that I have four equations in four variables, right, and our variables that we are assuming is f of x, f of x, f of x, derivative f of x, d square f of x, and d cube f of x, right? Again, we will use Cramer's rule. See, Cramer's rule is so helpful solving for the like some big equations, right? If it's Cramer's rule, this will just be d cube third derivative of f of x. Now in denominator, that will just be all the coefficients, right? So yeah, it's actually easy. Now in the first round, there will be 0, 0, 0. Now along with the coefficients, just go on writing the derivative of b, right? So there will be first derivative and no derivative 0, 0. There will be 2c1 the second derivative, 2c2 the first derivative, and then just wait 2c0 should be there at the beginning. I'm sorry, there should be 2c0 at the beginning. Okay, so 2c0 second derivative, 2c1 first derivative, 2c2 zeroth derivative 0. So 3c0 third derivative, 3c1 second derivative. Really? Okay, second derivative 3c2, and then first derivative, and 3c3 no derivative. Okay, and now over here numerator, just replace the last column by u, d square, u, d cube, and so on. So this will just be just the same first of all. So dfb 2c0 dfb, sorry, d square b 3c0 d cube b, right? And then 0 b 2c1 dfb 2c, sorry, 3c1 d square b, and then 0 0 2c2 dfb 3c2 dfb, and the last being replaced by u d square u, this column over here, right, this column over here, and then d cube u. Now again, as usual, if you try to evaluate this determinant, it's basically, since the main diagonal is just b, right, and this is just a lower triangular matrix, right? And also, if you know that the determinant of a lower triangular matrix is just the product of the diagonal elements, then it should be obvious to you, since it is a lower triangular matrix, determinant will just the product of diagonal elements, and just all the diagonal elements are b, and b. The determinant should be b to the power 4, right? So this is just uh, uh, 1 by b to the power 4, determinant of this thing. And over here in this thing, if you just want to swap the columns, first of all, you might want to swap this two, right? And now u reaches here, again swap this two. Now u reaches here, again swap this two, u reaches over here, right? So since there are three swipes, there will be three negative signs, and three negative signs product contributes to one negative sign, right? So there will be -1, and then this will be in first now du d square u d cube u, right? Notice that this negative sign is there only when in the odd derivatives. You might notice that pattern, right? For odd derivatives, there is negative sign. Okay, and then this is b db d square b d cube b, 0 b 2 db 3d square b, and then 0 0 dfb, and then 3 dfb. And that's what we are supposed to prove, right? That's what we are supposed to prove, no? Yeah, -1 by b to the power 4, determinant of u v0 0, and then du db v0 d square u d square b 2 db dv. Oh, 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 wait, wait. over here, over here, this is actually just v, right? This is not db, I'm sorry. This is just a v. Yeah, sorry. So if that's just a b over here also, that's yeah, that's just a b. I'm sorry guys. To b. Mm, guys, is it? No, that's not there. Not. It's over here. That's over here. Over here. Okay, that's just b. Okay, yeah, yeah. So now that's just b. So yeah, now it matches right. So that's just b. D cube b, d cube b, 3d square b, 3d. Yeah, that just matches. Now using this, this is in good pattern, right? This solution is in good pattern. Now using this, let's try to find the fourth derivative of the u by b. And I guess you guys still remember that this f of x is just u by b, right? Don't forget that. So yeah, this is just d cube of u by b actually, and that was our goal. That was our goal. Oh, I forgot to say that. Wow, I forgot to say that. How can I forget to say that? Okay, now let's try to find fourth derivative. This will be pretty simple. This is pretty same. So fourth derivative of u by b will be, so first of all let's try denominator. This will just be uh, b and then four zeros now, right? And then dv b 0 0 0 and then 2c0 d square b 2c1 dfb 2c2 b 0 0. Now again, this will be almost same just like in the previous determinant, right? I'm just seeing that and making copy. So d cube b 3c1 d square b 3c2 dfb 3c1 b and then 0. Last one should be 4c0 d4b 4c1 d cube of b. I mean third derivative of b. 4c2 second derivative of b. 4c1 first derivative of b. 4c0 b. Okay, yeah. So this is the denominator. And for numerator, just replace the last column by u. So b dv 2c0 d square b 3c0 d cube b 4c0 d to the power 4b and then 0 v 2c1 d of b 3c1 d square b 4c1 d cube b 0 0 2c2 b 3c2 d of b 4c2 d square b. And again there's still a lot more. So 0 0 0 3c3b 4c3 dfb and last one will be replaced, right? Oh guys, why am I, this should be 4c3, this should be 4c4, right? The value is same but still to make the, why am I decreasing this, guys? Even though the pattern is same but still, I mean even though the value is same but still 3 4. Okay, now in the last will be replaced by u, so this will be u du d square u d cube u d to the power 4u, right? Whew, and this is it for the fourth power. And now if you wanna like make the u at the front, so you need to first of all swap these two, and now u will be here. Swap these two, u will be here. Swap these two, u will be here. Swap these two, u will be here. So there are four swaps and there will be no negative sign. You can just do a cyclic permutation, bring u over here and take all of them one step back, 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 and there's no need to introduce a negative sign. And we also know that this determinant will just evaluate to b to the power 4, because it is again a lower triangular matrix, so determinant will just product of diagonals. So yeah, you can definitely do that. You can definitely take this to the first. Do you want me to do it? Okay, for the sake of completion I'm doing it. So this will just be 1 by b to the power 4, and determinant will just be u du d square u d cube u d to the power 4u, and this is b dv d square v d cube v d to the power 4v, right? And then 0 b, this is 2 dv, this is 3d square b, this is 4 d cube b, this is 0 0 b, 3 d of b, 6d square b, right? And again 0 0 0, this is p 4 dv, and last one is just, yeah, there's already a lot. You can, this is all. So guys, this is our final answer. And this is basically a problem for my. That was given to my friend, and the question was this question, to find the fourth power, to guess the fourth power, and yes, we have done it. So that is it, guys. Hope you enjoyed the video, and thanks for watching. Look forward to seeing you in the upcoming videos too.